So let's look at it another way. We're not saying that if you increase the force, will it go deeper into the ground. That's pretty straightforward, right? Does everyone see that? So if you press your finger into a cake, it's going to go further with a greater force, right? What we're saying is if you take a marble, let's take a marble, just think about it. Take a marble and drop it onto someone's birthday cake. It's going to go into the icing, it's going to go into the cake some, the higher you drop it, right? So if that cake is soft, it's pushing back a lot or a little? A little. And if it's pushing back a little, the force it's pushing back, then it's probably going to take longer distance. Okay, a less of force is going to take a longer distance, force times distance, to absorb that energy, right? To slow it down. Okay? So, if you drop that marble, okay, into a piece of clay, it's pretty hard, but you can push it around, and you drop it, and it only goes down about maybe a half a centimeter instead of 3 centimeters, then the force that the clay is harder, is pushing back is a stronger or weaker force? It's a stronger force. So the force is now higher, and what did we say about how far it went down? Much less. So you have the product of force times distance as a constant. You remember that in math, right? That was an inverse relationship, right? Force, when you have a product of two variables and they equal a constant, then as one goes up, the other does what? Goes down. And that's what's happening with the simulator. So we don't want to think of it as, would a harder force push it down more? We're thinking about the product of force times distance, okay? And that's how you want to think about this problem. What's pushing back? Is it a weak force or is it a strong force? And if it's a strong force, it's not going to make it far into the ground, okay? Does that clear a lot of things up for people?